So before we start this session on the introduction to C++, I kind of want to know how many of you have any experience with C, just plain old C. Okay, you guys have experience with that. Okay, that is good. So the good thing here is if you know C, you will know a lot about C++. You won't know the entire picture, but you will have the basic understanding required to go further. It's like you're already experienced with C++. So if you know C, you'll know C++ because C++ is a superset of C. That means whatever valid C code you write, it is also valid in C++. Okay. So why C++? That begs the question, why C++? Because there's a lot of languages. You have Java, you have Python, you have Scala, Kotlin. There are so many languages you could write millions of books about that. But C++, it's kind of a very fun language in my opinion. And the main reason why is because one, it is very, very verbose. Like you know what's going on. You don't have to worry about what type of variable is this, what is this, what is that. You don't have to worry about that. It's very fast because all of the code is compiled into your machine language. It's very, very fast. It is very efficient. And also you can write the same C code and compile it to multiple different architectures, and you won't notice any difference in the performance. Okay. Alongside that, for the more modern C++, you have a lot of object-oriented help. You don't have to worry about making everything variables and stuff. You can make entire related set of data as one object or a class. We'll get into more of that later. I'm just uh, putting out words there. You'll also have a rich library support because in this day and age, who actually writes code? Am I right? All we do is we find a library we like, we find a library that we need for our work, and we just take it and use it in our project. You don't need to know how it works. Same stuff like image processing or machine learning. In Python, you don't do all the stuff manually. You find a library you like, you install it, and just use the code. Why? Because stuff there, it's already very highly efficient, written by someone who knows better than you. Because for sure, that person who wrote the library that I'm using knows better than me. They know way better than me. So why not capitalize on that? So C++ is very fun. It's very intuitive. It's very, how would I say this? Very useful. So I'm not gonna drag on much on the like theory and stuff. If you want, you can read that. Okay, but I'm gonna show you how to actually write some C code and get started with this. So I'm assuming all of you have your editors of choice open, be it VS Code, Atom, Sublime, whatever you want. I am using VS Code, and we recommended VS Code because it's very user friendly for the beginners. So I'm just gonna start by making a new file. I'm gonna save this and name it as first.cpp, where .cpp is the preferred extension for C++ files. Okay, that just lets your code editor or your IDE know that you're working with a C++ file. So it can offer you something called IntelliSense, that is autocorrect or auto completion. Okay, so I'm going to name this first.cpp. And alongside that, I'm actually going to have my terminal open. For Linux and Mac users, it's kind of easy. You can just right click on your folder and it'll come like a open terminal here option. Yeah. But for Windows users, just click on this search bar on the top and type in CMD. That will open up a terminal at that location. Okay. So your code editor of choice, your terminal, and a new file. Name it whatever you want, and I name mine first.cpp. Okay. So if you guys have this ready, we'll get started with this. So can I continue? Okay, I'm gonna assume that as a yes. Feel free to stop me if you have any doubts or if you have any issues. So Yeah. Well, C++ has a lot of things, but one of the main things that you always have to have, one of the main things is a function called main. Okay, and the reason why it's named main is because it is the main function that runs when you run the code. It is the entry point. So let's say you write some code and you compile it. If you don't have a main function, your computer will not know where to enter, where to start from. Okay. In other languages, it might be other ways, because in interpreted languages, it always starts at the top of the file. But in compiled languages, you usually have a function called main. So I'm just going to start by writing that out. I'm going to just write int main and brackets. I'll explain what this means later, but just try this.
Pranav,
Yes.
can you please zoom in a little bit?
Oh yeah, sorry about that. I'll just. Is this fine?
Yeah, thank you.
Let me also. In, I also have this thing on, so we'll see what I'm typing on the bottom. Yeah. So this is just what every C++ file requires: a main function. Okay. And inside this, I'm just gonna, well, we'll fill the inside data. We'll worry about what int main is actually data. Now, like I said, main is the entry point of your C++ program. So whenever you compile your code and you want to run it, your computer always searches for this function, this signature main, and goes inside and runs it, starts your execution. These brackets, you see these brackets, they are there for your arguments. We don't need to worry about arguments much because it's not that highly used. Like the command line arguments, you'll usually have some kind of other input, or you won't have any input at all. But that just defines that this is a function and it has no arguments because you're not passing anything to it. This int is the return type. So what int means is it's going to return back an integer. That integer is actually the error code or the completion code, if you want to say that. It's like if the code worked or not. Like if it worked, great, it give me one kind of number. If it doesn't work, another kind of number. If some particular error happened, like let's say you missed a com or missed a quote or something like that, it'll throw a particular number for that error code. That is what it means. It's returning you back a number. And these braces are just there to contain all your code within main. And so I'm gonna start this out like every programming tutorial ever. We're gonna print out hello world. Okay. Now C++ has a lot of, like I said, a lot of libraries you can use. And one of those libraries we're gonna look into now is called IOStream. IOStream stands. I'm just gonna do it. IOStream stands for. It stands for input and output stream. Okay. So it basically handles, like the name says, it handles all inputs and outputs. And the way you use your libraries in C++, okay, is by using the include statement. So it goes like this: hash include is less than symbol, and you should see something like this: IOStream. So you do a hash include IOStream. That allows you to use the IOStream libraries, IOStream functions in your code. Okay. And after this, to print out something to the console, we do this. We type in std : okay, C out and two less than brackets. And then just I'm gonna give a string hello world. This is the simplest you can get with any C++ program. It's just having a single main function with a single line of code that says print out hello world with a space in between. Okay, we're gonna walk through what this std cout and these two things are, and why when I'm using double quotes. Okay, we'll walk through that later, but for now just write this out. Everyone done writing this? Just typing this out? Yeah. Okay, so after that, after you're done typing, open up your terminal, Windows is the cmd, the command prompt. Okay, make sure you are in the same folder as your file, and then use the g++ command to compile your code. And what I mean by use the command to compile your code is just do this g++, and then give your file name first.cpp. If I hit enter, it'll take some time, and afterwards it's not gonna print anything else. If it doesn't print anything else, that's really good because it means there's no error. Okay, and you should find a new file in the same folder called a.exe, or for Linux and Mac it should be called a.out. It'll be a dot something for you guys. Okay, for Windows it'll be exe, for Mac and Linux it'll be a.out or something else. So this is the code I wrote, and this is the command I used. Did anyone have any issues with this? Did everyone just okay? No issues with this. Okay. Now you have G++. You did that. You compiled your code. It didn't print anything. That means there was no error, and that's a good thing. So how do I run it next? Well, since you're still in the command, since you're still in the terminal, and we know that the file name is a dot something, just do this a dot. It's exe for me, so I'm just going to type exe and hit enter. A.exe and just hit enter, and it runs. So I got what I typed. I got hello world. Okay. So the way any C++ program works, like a single file program works in the beginning, you just write your code, make sure you have a main function, int main brackets, and whatever code you want to start out with in the function. Save your file, go to your terminal, use the command g++ first.cpp or whatever file name.cpp. It'll give you an output of a file called a.whatever, a.exe or a.out, and just type the name. For Linux, by the way, for Linux and Mac you'll have to actually prepend that with this /a.out. For Linux and Mac, you actually have to do /a.out. A.out will not work. So for Linux, same thing, g++ whatever, but you'll get a.out and just do a /a.out. Okay, anyone having any issues so far?
Nope.
No? Share my screen. So we're going to walk through what this code actually is. So I told you what int is. It's a return type. It's what the code returns. Main is the main function where your code starts execution. Hash include is a way to include external libraries so that you can use their functions, the functions that someone else wrote, someone else who has more experience with this wrote. IOStream is the name of the library that we use for input and output. Okay. So inside this, you'll see std : cout and hello world. Now, I'm gonna tackle this part first. What do you think this is? If you learned C, you'll know why I'm using double quotes there, right? If you've learned C or learned any programming language, you'll understand why I'm using double quotes. And the reason for that is, in in any language, double quotes means it's a string. And what is a string? A string is, well, it's like what to define in English. It's a set of characters. A character is just an alphabet. Okay, a set of them together is called a string. In C++, you denote strings by enclosing them within double quotes. Okay, the cout is the function which outputs to your console. That's what the C in cout stands for, console. Cout is literally, it says console output. Okay, so whenever I run that program, it outputs to my console. This is my console. It outputs to that. There's less than operators. Those two things, they are called indirection operators. Again, I'm just telling you this. You don't need to know this to write the C++ code. It's just something. It's good to know it, but you don't need to know it. Again, so less than is an operation that pushes anything that's on the right side into this thing. So it's pushing this string out to this function, which pushes the string back out to your console. Now, the most important part is std::. Now, C++ can get very complicated. And I am telling you this out in the beginning only. It can get very complicated at higher levels. And one of the main problems they have is repeated function names. So let's say I'm writing a library and I want to have a print thing. I want to emulate C's print or Python's print function. So I'm going to write a function in print. You also want to develop your own library and you also make a function called print. Now, if one of our friends wants to use both of our libraries and he doesn't hash include my library, hash includes your library. When he tries to compile it, the program will have, it just freak out. Why? Because you have a print statement, print function. I have a print function. And since print just prints out a string, it will be the same return type, it will be the same function name, same arguments. It won't know which one to pick. And a very useful way of solving that is to introduce something called namespaces. Basically enclosing a set of functions inside a namespace. Here the namespace is std, which stands for standard, because iostream is part of the standard library. Okay, so if you ever want to use any iostream function, you have to prefix it with std::, which means go into the std namespace and then use the seer function. So if I write my library and then name the namespace to Pranav, that's my name, I'm going to do Pranav, and then I'm going to write my cout function. There will be no way the compiler can confuse between your function and my function, because they are both in different namespaces. Okay, that is why we have the std::. But, and I get this all the time, people always say it's kind of tiring to write std::, all the time in every single function. I don't want to do that. I just want to write code. I don't want to write std::. There is a way to stop that. So I'm just going to remove this for now. Let it throw an error. So it says identify a cout is undefined, because it's defined inside the namespace, so it's not outside it. It won't know where it is. I'm going to fix that issue by just using a single statement. Okay, I'm going to say using namespace std and a semicolon. It is gone. If I compile this and run it again, still works. Yeah. So what this line is doing is it's saying any function that you see, any function, literally any function you see, if it's not defined in this file, make sure you check inside the std namespace first. Check inside the std namespace And if it's not there, only then throw the error. So this removes my need to put std cout anywhere else. Okay. So so this is just the basic stuff. So next we're gonna move into data types. What are the different kind of data types there and how to use them? Before I go there, do you guys have any doubts? Did I go too fast? Did I go too slow? Any feedback, so I can just change my teaching to your style. If you want me to go like a bit more slower, like take my time, walk through this, let me know and I'll do it.
Proper enough.
Yeah, I couldn't hear you. Sorry about that.
It's proper. The pace is fine.
It's fine. Thank you. Everyone else good with this? Okay, I'm gonna assume it's good with this, so I'm gonna stop this and I'm gonna go with the next topic. I'm basically following every lesson plan ever, just walking through a basic hello world and then variables, data types, blah blah blah. So I'm gonna close this. I'm gonna make a new file. I'm gonna name it data types.cv. And don't worry, if you want, we'll be giving you these source codes, so those files later. Okay, so try to understand how it works, and any change I make, it's fine. I'll let you know. Okay, so we're gonna go into data types. Again, what's the one thing that every C++ file needs? A main function. So we do int main and just this. And I obviously want to output stuff, so I need to include the IOStream header, IOStream library. Okay. I'm just going to use the entire std namespace. Okay. And I'm going to print out this is a new file. Oh, by the way, comments in C++ are this slash. It's so you don't need to actually type out devices every time. Just hold control and the slash button, control slash, and it will output the command comment for you. So we're gonna go into data types first. Data types. Now C++ is a very strict language. And I don't mean it like scolds you for doing something wrong. I mean, it does scold you. It does throw out very nasty error messages. It does scold you for writing wrong code, but that's not what I mean by strict. By strict, what I mean is it is very strict in type checking. Any of you have any experience with JavaScript or Python, or the new language Julia or something? And if you have any experience with that, if you do, you'll know that JavaScript and Python are very loosely typed languages. And it's called loosely typed languages because they don't really care what your type is, what your variable type is. Like it can be an int at one instance, the string at another, character at another, decimal, float, whatever floats you boat. They don't really care. But C++ does. And it's very strict in checking what data type you're using. So we have to go through a list of data types, the most commonly used data types in C++. So there is the first, the most important, the one that we all use every day, is an integer. Integer, I can't spell. Yeah, it's integer. And next you have a floating point number or a decimal number. You have a character. You have strings. You have booleans. So before I show you what an integer is, I want to show you how to declare a variable. Declaring a variable. So in C++, all variables, the variable names have to adhere to a strict standard. So what is it? So you can't have the first character being a number. Okay. It can't be a number, and the variable name cannot contain spaces. Okay, and that's basically it. No numbers and no spaces in the beginning. So this is a valid variable name. I is a valid variable name. So anything I want, I can give. So you can give. I can even give my name as a valid variable name. Okay. And before that, you need to declare the data type. Data type, and then the name and a call. So let's get started with integers. What is an integer? An integer is your, if you're if you remember your math courses, it's just the integer is a whole number, and whole number from negative infinity to positive infinity, the entire range. And the way you declare an integer in C++ is through the keyword int, int. So int, I'm gonna name my integer variable, integer variable, I can't spell, and so integer variable is a type of int. So it can only accept numbers that are whole numbers. It cannot accept decimals. It cannot accept strings. It cannot accept characters. And you can just verify that by just hovering over it, and it will show you int integer variable, data types integer. Same way for float. What is a float? A float is any decimal number. So it is basically some integer, a dot, and another integer. The way I declare an integer floating point number is float and float variable. Okay. A character. A character is just a single alphabet, or it can also be in integer. Anything that's enclosed within like a single code that counts as a character. And the way you use that is with the keyword char or char, however you like to pronounce it, it's up to you. I just say character only. Character, and I'm going to name it character variable. Okay. I'm going to turn this off and distracting. We'll skip strings for now because strings kind of depends on another library. Okay. We're going to move on to Booleans. Now, Booleans are kind of interesting. Why? Because they can only have two possible values. Booleans are actually named after a computer scientist. His name was something Boole. His last name was Boole. That's why they named Booleans after him. And it can only hold two values, one of two values. It can be either true or false. So whenever you like asking a question, like I ask you a question, is this your name? You will be answering in a Boolean, yes or no. Okay, so basically like it's some kind of interrogation, just answering in yes or no. All of that is a true or a false that's contained within Booleans, and that is within Bool. So we have Bool variable. Alright. So we now have the basic four data types: integer, float, character, and Booleans. Okay. Now the strings issue with strings is C++ does support strings. They have a string data type, but it's not like it's not like you can just you can't just type string something. Come here, but you also need to include if you just want to use it, it's fine, you don't need to include it. But if you want to use its properties, like creating a substring or like splitting it off based on some delimiter or reversing it or making it capital, for those kind of stuff you need to include this string header. But even if you don't include it, it should be fine. in most places. Okay. So these are your basic data types: an integer, a float, character, integer, float, character, boolean, and string. Now we have these things, but they don't have any values. Like, we just declared them. It's called a declaration because it is saying integer variable is a variable of type int. We're not saying, it has so and so value. It doesn't. We're not saying it has value of 10, not value of 20, value of 30, value of 40. Just declared and kept it as is. When you want to give it a variable, you use the equal operator, the assignment operator, and it's just this. I'm gonna initialize it here. Integer variable equal to 10. And do note, all of your lines of code have to have a semicolon at the end. Okay, if they don't, it'll throw an error, because C++, the only way it knows if you've gone to a new line, like a new command, or it's the same command, same bit of code, is through the semicolon. So if you put a semicolon, it means you're telling the compiler that I am done with this line of code, I'm going to go to the next line. If you don't, the compiler takes all the lines as one line. Okay, so here I am setting value of the variable to 10. Now, notice how, remember how I said C++ is very strict in type checking? Imagine if instead of doing 10, I do 10.9. Does it throw an error? I mean, it should throw an error, right? Logically, it should. Because I told you, an integer will only accept integers, not anything else. Then why is it accepting 10.9? It's not throwing an error. It shouldn't make sense, but it does. If you haven't, okay, if you know why, just feel free to tell me. I saw someone unmute themselves. Okay, no one? Okay.
It converts the float into an integer.
Exactly. So since floating point numbers are also, technically numbers, you just have the extra dot and some number bit at the end. C++ just chops that bit off, like it chops 10.9 into just 10 and stores it. So for floats, that works. But if I do this, it doesn't work. But look at it. A value of type const something something can be assigned to an entity of type int. This is not an integer. I mean, it looks like an integer because it has the the number 10 inside it, but it is enclosed within double quotes. That makes it a string. So you can't set a string to an integer because there is no way for the compiler to actually convert it to a string, convert into an integer. There are ways in which you can do it, but the compiler will never do it. It just tell you to do it. So that is why C++ is kind of favored. So you'll never have these kind of misunderstandings between you and the compiler. It will always tell you what data type it is expecting and what you gave and how you can fix it. So in this case, if I just remove these quotes, the error is going to disappear. Similar to how I set the integer variable, I'm also going to set the float variable as 3.1415. I'm going to set the character variable as a. Also, strings, while strings use double quotes, characters always use single quotes. Make a note of that. So if I give a double quote here, it'll actually throw an error. Because a string is technically not a character. A string is a set of characters. It's not just one character, it is many, multiple, all together. That is a string. But a character is just one character, like just one alphabet. So you can't push a character, like a string, to a character. Okay. And I'm gonna set the Boolean variable as false, and I'm also gonna set the in this string variable as hello. Okay. Now, even though I declared it here and initialize it here, like I set the values here, you don't need to do that. You can even do it here. This is no issue. You can initialize on declaration, or you can initialize after declaration when you need to do it. Both styles are the same. There's no noticeable performance difference in anything. It's just a way of, your style. It's your style of coding. If you feel comfortable doing it during declaration, go ahead. If you feel comfortable doing it after declaration, when you want, like if you're thinking I'll declare everything first and then I'll initialize everything later together, so keep it, more compact, more clean, more crisp, go ahead. It's up to you. Doesn't really matter. I'm just gonna do this. So, do you guys have any doubts with the data types we have? Integer, float, character, boolean, string, and yeah, that's it. Any doubts on that? So all of you know the basic data types now. Okay, cool. So you know how to declare one, you know how to initialize one. What next? How to use it? So before I go on to like showing you more like operators and stuff, we're gonna go into just seeing how to output these variables onto the console. Similar to how you did the cout and give a string, you can also do cout and give your variable directly. Integer variable. Okay, so I'm gonna compile this C++, the types.cpp. Nothing outputted, so it means compiled properly. And then I just run a.exe. This is a new file. This is a new file and prints 10 because the integer variable, the value of the integer variable is 10. Okay, but here I wrote like this, and I wrote it like this here in different places, but still printing in one line. Why? So here's the thing about C++ and in extension C, they give you complete control on how your entire program works, like a lot of control. Okay, and the reason is printing in the same line is because I haven't told the computer, hey, I want this in the next line. I don't want it in the same line. I want it to go to a new line, go to the beginning of the new line, and then print the variable. I just said print it, and it just printed it. It's not wrong, but it's not what I wanted. So I'm gonna make it print to a new line. How do I do that? So there are things called escape characters. Okay, that is prevalent in almost every language, and it's the fundamentals of printing to your console or your file or whatever. Okay, the most used control character you see is the /n. /n is the backward slash and the n. That means go to the new line. I'll show you how that goes. I'll show you what it does. Again, every time you make a change, remember, just compile once again. Because if I run this and the old file again, expecting it to work, it will not work. This has happened to me many a times while working on projects, and it's often good practice. Every time you want to run your code, compile it once again and then run it. So just in case you forgot to recompile it, you don't have to worry about it. So I'm gonna compile and run. Now look at the old output, look at the new output. It was in the same line. As soon as I added this /n, it came to a new line. So that is what /n does. It moves this thing. I don't know what it's called, but the typing thing to the next line, the cursor to the next line. Sorry. So it prints. This is a new file. It encounters the slash n here, it moves the next line, and then prints the integer variable. And the integer variable value is 10, so it prints 10. Okay. So anyone have any doubts so far? No, right? Similar to how you printed out an integer variable, you can print out other variables. So I'm just gonna copy this entire thing. Yeah. Replace this here, replace this here, and replace this. Okay. Now, remember how I said you can use string, but anytime you want to do something with it, like printing and stuff, you have to include the string header. This is the reason why. All of these four data types are basic ones. They are primitive. And by primitive, what I mean is it's the fundamental base data type which everything derives from. Okay. And string is a derived data type which derives itself from the character data type. Because string in its essence is a set of characters. It's a collection of characters. So without a character, you can't have a string. And to output a string, you have to include the header hash include string. As soon as I add that, this header disappears. Okay. And I'm gonna compile and run. Again, I didn't add a new line here, so this happened, but I'll show you how to fix it there. So 10, 3.1415, A, 0, and hello. So one thing you can do is you can push multiple items to the console at the same time. What I mean by that is, since I put cout integer variable here, there is nothing stopping me from doing this here. So basically what this means is push integer variable first, then push /n. Okay. So if I compile this and run, after 10, there is a new line. And this can be chained for how much ever you want. It won't matter. All it does is it's just saying after you push integer variable to the console, please push the new line character. So instead of having all of this, I'm just gonna replace this here. I'll go back. And in between, I want a new line. So my options are either to put the /n or I can put endl. The endl stands for end line. Endl. So I'm essentially just ending that line of output. endl. And because you put this statement there on top using namespace std, you don't have to put std : endl. You just put endl. I'm gonna compile this, run again, and everything is in its own line as it should be. Okay. So yeah, this is it. or this is all there is about data types. You can learn more about this, but from my experience, from what I've learned with learning C++ and using it in projects, you will not you'll typically not use more than this. Okay, because every single other data type will will eventually derive from this. So if you know this, you can get to get yourself familiar and use it quickly with the other data types. So I'm gonna make a new file now. I'm gonna name this operators.cpp. Again, same speed. Hash include iostream for input output. End main, because everything needs a main. And using namespace std because I'm tired of typing out std colon every time. And this is our boilerplate code. So what comes next is operators. Okay. So what do you mean by operators? Well, operators is when like how you define operators in math. The plus, minus, divides, multiplies, those kind of operators. Now, those operators behave differently for different stuff. And all of that is written well into the C code, C standard. So you don't need to worry much about that. Just remember, it's just like math: add, divide, multiply, subtract. So we're gonna go into first arithmetic operators. So I'm gonna declare a new variable, new integer variable called a, and I'm gonna set it to 10. I am going to print out a in a line, and then I am going to multiply a by 10, and I'm going to print a again. Okay. So I am setting a to 10. I'm printing it out. I am multiplying by 10, and I'm printing it back out. So if I compile this and run, oh wait, the wrong file. Sorry, my bad. Operators cp and run a.exe. I printed 10 and again 10. This multiply didn't hold. Why is that? Well, here's the thing. When you multiply an integer or anything, okay, it often doesn't affect the variable you're multiplying with. So a star 10 will actually multiply a by 10. That's not wrong. But it will not modify a. And if you want to modify a, you have to store it back. So a equal to a star 10. This bit will multiply a by 10, will give you 100 in this case, and this bit will store it back into a. So essentially you're multiplying and storing it back. You're modifying the data, you're multiplying in place. So if I do this and I run, I add again operators and erotics. So it's a 10 and it's 100. Okay. And this goes for everything else. So I can just do b is equal to 10, c is equal to 10, and I can show you b is equal to b plus 10, b is equal to c is equal to c divided by 10. And I can print out e and c. Copy this line and print out here. So in the beginning, it was all 10, 10, 10, 10, and then became 10. So it became 100, 20, and 1. So 100, 20, and 1. So That is almost all there is to arithmetic operators, to be honest. It's just your basic maths, you know, multiply, divide, add, subtract. I mean, you can just subtract, do this here, and it will work. But stuff that is important to computers, the operators that are kind of important to computer science is logical operators. There is one more I'll tell you later. So first step, we go with logical operators. Now, what do you mean by logical operators? So logical operators refers to the set of operators which apply on Booleans. They are a set of operators that apply on Booleans. So what does that mean? They are the AND, the OR, the NOT, the NAND, and the NOR, the XOR, those kind of operators. But basically, the three basic logical operators are AND, OR, NOT. Got it? AND, OR, and NOT. What do I mean by logical AND? Logical AND is, so if I have true and if I have another true, have true, and if I have another true, and I do a logical AND between them, this is spit out true. But if one of the variables becomes false, it's false. So that is what AND means. AND means both the variables have to be true. If either one of them is false, the entire thing is false. Okay. Similarly, we have OR. OR, you know, like the name implies, either one of them can be true. Like A can be true or B can be true to have the output as true. Okay. If either one of them are false, it doesn't matter much as long as the other is true. You only get false during an OR operation, during a logical OR operation, if both the variables are false. And NOT is, you know, it's just not. It inverts whatever you give. So if you give it a true value, it gives back you a false value. If you give it a false value, it gives back a true value. Okay, and in C++, those operators are defined through this. The AND symbol is this. The OR is this. And the NOT is this, the exclamation mark. So this is two ampersands, two, I don't know what those are called, but they're like a pipe. It's a line, of vertical line, two vertical lines, and for the NOT you have the exclamation mark. So I'm going to declare two variables here. Bool, bool1, I'm going to set it to true, and bool2, I'm going to set it to false. Okay. So I'm going to print the outputs here. So I'm going to do cout, okay, 1 and 2. I'm going to end this with a ending character. So I don't want it to in the same line. I need to enclose this within the bracket. All right. Okay. Similarly, I'm going to do an OR operation here. And here I'm going to do not 1. I'm going to do not 2. And I'm going to end it. Okay. So I'm going to compile this, run this. So forget these two bits because that's from the previous outputs. We have true and we have false. So what is true and false? It will give me a false. In C++, any number that is not 0 is true, and if the number is 0, it is false. So that's why it's printing out 0 here, because false is represented as 0. False is 0 and True is 1. True is, well, it's not 1, it is just not 0. It's just not 0, not false. Because true is technically it's not false, so it's not 0. So it can be any other number. So we have true and false as this. 0 because true and false is false because one of them is false. True or false is true because one of them is true. And 1 was supposed to be true, not 1 is inverted false. 0. True was supposed to be false and inverted it is 1. It is true, so it is 1. So those are your logical operators. And the final bit set of operators are the bitwise operators. So I'm assuming you guys know how a computer works, like at least how a computer stores data. I don't mean in depth, like a representation. So the way a computer stores data is in the form of bits. Okay, basically zeros and ones. So a computer will store all your data, everything, even this, even your Chrome, even your Windows or Linux or Mac or whatever operating system, even the voice that I'm sending to you, even my speech, it's all transmitted to you as in the forms of zeros and ones in your computer. Okay, so 0 is like a low state and 1 is a high state. That's how everything is stored in your computer. That's how everything is represented. So it's often helpful for us to act directly on those base level of storage, like storing something as 0 and 1s and multiplying stuff with that, moving it to the left, moving it to the right, subtracting stuff. That's often useful. And the reason bitwise is because it operates on the bits. Now bits are stored as it's basically binary. So binary notation is base 2. You only have 0 and you have 1. So we have the set of bitwise operators, that is this thing, which is the bitwise OR. We have the bitwise AND. Okay, we have the left shift. We have the right shift. Okay, and some standards also do call for this as the 2's complement, but you don't really need that much. And if you do need it, you can always use it. But the basic bitwise operators that always used is this, the bitwise OR, the bitwise AND, the left shift, and the right shift. Okay, so we're going to start with the bitwise OR operator. Okay, so the bitwise OR operator is, it's similar to the logical OR, but it works on bits. It works on zeros and ones. So if you have a 0 or 0, it is it's false and false, or false is false. But if you have a 0 or 1, output is going to be 1 because it's similar to false or true. The sum of that, the expression evaluates to true. So I'm gonna do this. I'm gonna have a integer 1, which in binary is integer 1 equal to 1. I'm gonna name it X. There's already a 1 here. So which 1 in binary is just 0 1. I'm gonna have an integer y equal to 2, which in binary is 1 0. And I'm gonna have an integer z equal to 3, which in binary is 1 1. I'm also gonna have another one, w, as the base 0. Binary is 0 0. Okay. So first thing is the bitwise OR. So I'm gonna print w or x. Okay, I'm going to print W or X. So this thing is the binary bitwise OR operator. So what is W? It is 0. And what is X? It is 1. Okay, it is 0 and it is 1. So if I do a 0 or 1, the output should be 1. So we'll check that later. And next I'm going to do the same thing with an AND, but here I'm going to AND Y. I'm going to AND Y with Z. Okay, and then I'm going to left shift X by 1 in one position. And what I mean by left shift is, so this is how it works. What is my X? My X is 1. So in binary, it is 0, 1. And I mean, when I say left shift by 1, it translates to move everything to the left by 1 place and fill the empty spaces you just made with zeros. So this 1 moves to the left and becomes 1. And there's an empty space there, so it fills with 0. And 1 0 in decimal is 2. So left shifting any number by some digits, okay, will move the bits to the left for that many portions and fill the gaps with zeros. Similarly, for the right shift, it moves everything to the right and starts pushing zeros on the top. So I'm going to do for left shift, I'm going to do right shift on Z. So this is basically 1 1 left shifted by 1, which makes it 0 1. It is in decimal equal to 1. Okay, and you know what? I'm just going to cover it. I'm going to cover this also, the not. So if I do a cout and I do a not 3, not Z, and do a handle. So Z is 3, binary is 1 1. Bitwise operators operate on all the bits. So it first negates the first bit. So not 1 1 will negate the first bit to become 0 and negate the second bit to become 0. Okay. So I'm going to compile, run this. So up until here, these two was the arithmetic operators. These three were the logical operators. And now these are the bitwise operators. So we'll come to the first one. It is saying 1. Why is that? So W is 0, X is 1, 0 or 1 is 1. Makes sense. Next. And Y and Z. So 2, 1, 0, ANDing with 3, 1, 1. No, AND gives you a 1 only if both bits are 1. So look at these two bits first, 0 and 1. This one is 0, so the output will not be 1, output will be 0. So here 1 0 is being ANDed with 1 1. This will give me 1 because these two bits are 1, so output is 1. And because this bit is 0, the output is 0 here, which in decimal is 2. So I got 2 here. Got it? Next, left shift. So it is 1 left shift by 1 decimal, one position, 1 bit position, that gives you 1 0, that is 2. And this one Z, right shift by 1 position, so 1 1 becomes 0 1, that is 1. Got it? Last thing is this negation. So what we were expecting is 0 to become, sorry, 3 to become what? 0, 0, right? So like I said, this is the 2's complement. So in your computer classes, in your theoretical classes, this is how we'll say it is. Negation should work like this. But what actually does it gives you a negative form of that. So if you give it like 2, it'll give you negative 2. It's a way of showing negative representation of numbers in there. So I'm just going to keep it as is, but it's not used much. So we got the binary things, the binary or, binary and, binary left shift, binary right shift, and binary negation. So I want you to check something. Wait, before you do that, do you guys have any doubts? Anything at all?
No.
No doubts? Okay. So if you understood this, I wanted to try something. Now here I did x left shift 1. What happens if I left shift by 2? Can you tell me what the value will be? X is 1. If I left shift by 2, what will the value be?
100.
Yeah. So what is 100 in decimal? So 100 is in binary, right? So if I want to convert that to decimal, I'll be multiplying that by 2 to the power of 0 plus 2 to the power of something.
4.
Do that. Yeah, it'll be 4.
2,
Good.
8.
No, it'll be 4. 100 in decimal is 4. Okay. Now I'm gonna change this to 1896, and I'm gonna change this to, yeah, let's give this 2 only. So what do you think the decimal output of this will be? I don't want the binary thing. I want to tell me what the decimal output of this will be. If I make this 1896 and I give this 2, what do you think the decimal output is? You don't have to be right. You can just you can guess. It's fine. If you want, I just tell you why it's the value it's supposed to be. Okay, no guesses?
Is it right in assuming that it will increase 3 places again?
No. Left shift by 2 will move it 2 bits to the left. So it's not like if it's 1, it'll move it to 4. If it's 4, it'll move it to 7. No, it's not like that. The bits will move to the left, not the number on the number line. Okay, so I'm just going to tell you this. The bitwise operators, the left shift and the right shift, are very, very useful. Why? So I'll just show you this. So let's say I have, so it's in a new file. Let's say I have 2, 3. 3 in binary is 1, 1. If I left shift by 1 place, this becomes 110. And 110 is 6. Okay, 110 is 6. What's the relation between 3 and 6?
Multiplied by 2.
Okay, so if I make, so I'm gonna make this 5 now. 5 is 101. Left shift by 1 will give me 1010, and 1010 is 10. So do you understand what I'm getting at?
It's the double of that.
Yes. So this will actually make it so 5 left shift by 1 is actually 5 into 2 power 1. And this, if I make it 2, it's like 5 into 2 power 2. So if you ever want like really quick multiplication by 2 and division by 2, finding the powers of 2, you don't need to multiply it by hand, like putting in a loop and stuff. You can just left shift or right shift. So since left shift has the effect of multiplying by 2, what is the effect of shifting to the right?
Divided by 2.
That's division.
So division by 2. So if this is 1896, what is left shift by 1?
1896 into 2.
Yeah, that is it. So that is the importance of bitwise operators. If you normally try to do this, what you would do, you do 1896 into 2. That would by itself get converted into binary by the compiler. That adds as extra step of unnecessary work. So using bitwise operators lets the compiler essentially skip that entire step of converting from human readable decimal to computer readable binary and just do the binary math. Oftentimes, in your college stuff, in projects, it won't make much of a difference. But if you're doing like a lot of work, stuff like high frequency trading, where nanoseconds could mean the difference between losing billions or making billions. Those places, every nanosecond, every millisecond, everything counts. There, you'll often find a lot of bit magic. You'll see some code where they'll do left shift by 20, right shift by 20, multiply it by 10, negate it, or with some number, all of that to do some kind of math. They're essentially trying to break that one step, trying to skip that one step of converting from decimal to binary. So did you guys understand this operator stuff? Arithmetic, logical, and binary, very bitwise? Okay, cool. So if you know this stuff, you should be able to write like a basic program. Like this, getting like printing something, multiplying some stuff. But the most important part of programs is inputs. Like everything we do has an input. Even the code the editor I'm writing my code in needs an input from my keyboard. So you need to have a way of handling inputs. So I'm gonna show you how to handle inputs now. So same library we're gonna do. We're gonna do the same thing. Int main, and the library for input output is IOStream. So I'm gonna hash include IOStream, and I'm gonna do using namespace std, and I'm gonna declare an integer variable a. I'm not gonna set a. I'm not gonna give a value. I'm just gonna print a and end of the line for now. Here we'll take an input. Okay, so you guys know what cout is, right? Cout stands for console output. So can you guess what the function might be for inputs? Any guesses?
Cin.
Cin, yeah. So it is Cin, that is console in, and I'm going to take the input and I want to put it in a variable because I want to store it somewhere. So for cout, it was left shift, like the less than arrows, because I wanted to push this thing to the output. I want to take something in, so it's the other way around. So I am doing Cin A. I'm going to take the input and push it to this integer variable a. So let's compile this. G++ inputs.cpp, choose a.exe, and it's waiting for something. It keeps flashing. That means it's waiting for my input. So I'm just going to type 100, and it prints back 100. Okay. And I'm not like stopped at only giving one number. I can say in a comma b, and similar to how I can give multiple stuff to cout, I can take in multiple stuff from cin. Compile again and run. I can give 100, and I'm gonna put a space and give 89. Wait, not a space. 100, enter, and 89. Oh, I'm not printing B, my bad. I'm gonna print a space there. I'm gonna print B. 8 800, 89, 100 and 89. Got it? So this is how input works. So far we've covered the basic structure of a C++ program. Okay, its data types, how to output to the console, and what are the operators for the data types: the arithmetic, the logical, and the bitwise operators. So what we're going to do next is something called looping. So looping is basically a way of, it's like saving you from doing a lot of work. It's like this. Let's say I want to bake a, how do I say this? I want to bake a cake. Okay. But I don't want to bake just one cake. I want to bake multiple cakes, like 10 cakes. And how would I do that? I would just, say make one cake, and then again make one cake, and then again make one cake, again make one cake. If I wrote it through code, it'll be like make cake function again, how much ever times I need. How many times I need, I just put the call that function. Now this will work. I'm not saying this will not work. This will definitely, most definitely work. And it's not going to throw an error. It's going to work beautifully. But it doesn't look that good. And it's not that easy to handle, maintain. So let's say I wrote this. I know what it does. Let's say I pass it off to another person who wants to make their own cake. They don't know what this does. They don't know why I'm doing it so many times. They don't know how I'm doing it so many times. They just want to make cakes. So it's often easier, instead of writing all of this, to write it inside a loop and just write it once. Instead of writing calling the same thing multiple times, we will write a loop and just write it out one time so that we let the compiler handle it multiple times. We don't need to see it. So did you guys, so that's why we need loops. So I'm going to show you how to write loops. I'm actually going to make a new file. No, I'm just going to rename this file to in loops and inputs. So loops. C++ has three kind of loops. They are all kind of similar, but they're just written different ways. Okay, they're kind of similar. They basically they work the same way, but they're all written in different ways and are often useful in different situations. So the first loop, the while loop. So it's like in English, it's like saying, while I am not tired, I will not sleep. So what does that mean? So I'm gonna keep on checking if I am tired. If I am tired, I'm gonna sleep. If I'm not tired, I'm not gonna sleep. Or like, while not thirsty, don't drink water. Or like, while hungry, eat food. So it's like this, while, and then whatever you want to loop. I want to loop printing a multiplied by 10. Just a. I want to loop a. I want to print a multiple times. Okay. Now there's an error here. What does it say? Expected an expression. That is the main part of any loop. You have to give a condition as to when the loop should end, or like when it should actually run. Okay, when it will stop running. So that is called the condition of the loop, and it expects a Boolean. So you'll be using your logical operators here. Okay, so that's the importance of logical operators. Just checking if you are able to run the loop, or like checking some kind of condition. So for writing conditionals, use logical operators. So let's say I want to run this loop. Okay, I want to print out, instead of A, I'm going to print out yes. And since I'm gonna be taking an input of A, I want to print yes for how many times I have A. So if A is 5, I want to print yes 5 times. So while A is greater than 0, and inside I'm gonna do A is equal to A minus 1. What does this happen? What happens? So I'm gonna take an input of A. I'm gonna check, is A greater than 0? Yes or no? So let's say my input is 5. A is greater than 0, 5 is greater than 0. That's true. So I'm going to go inside this loop. I'm going to print S. And then I'm going to decrement the value of A from 5 to 4. Now, if it comes here, it goes back to here. Is 4 greater than 0? Of course, absolutely it is. So it goes back in, decrements, comes up here. 3 greater than 0? Yes. Goes in, decrements 2 greater than 0? Yes. Again, 1 greater than 0? Yes. And when you have 1 here, this becomes A becomes 0. Is 0 greater than 0? It is not. So then this thing ends. So if I compile this, like say 6, I have 1, 2, 3, 4, 5, 6. 6 times S got printed. So instead of doing this, 1, 2, 3, 4, 5, 6, I just have to do this. So this is very variable, because I can just change the value of A and have it do multiple times, but this is very static. So if let's say the client asks for yes to be printed multiple 100 times, I'll have to copy and print it out 100 times. But if I have a loop, all I have to do is just do while I'm gonna set A equal to 100, and while A is greater than 0, do it. The print for 100 times. So now your code is more flexible, it's more intuitive, it's shorter, it's much cleaner, and it's very easy to be understood by others. Okay, so this is a while loop. Next, I'll do the other kind of loop. What is it? A for loop. Now, notice the parts of the for loop, of a while loop. So in the while loop, we have the declaration of the variable here, A. We have the condition here. Okay. And we have the increment or the decrementation of the variable here. Now, for a for loop, you just take those 3 bits of a while loop and just combine them together to a single line. Make them a single line. That is it. That's all there is between a for loop and a while loop. It's just syntactic sugar. It's a very cleaner approach of describing while loop is a for loop. So it's like for int I equal to 0, I less than 100, less than 10, I plus equal to 1. Okay, I don't think I told you guys about this plus equal to operator. So the plus equal to is actually a shorthand notation for writing this. So this can actually be written as A minus equal to 1. So this plus equal to, minus equal to, star equal to, slash equal to, they are all shorthand notations. So you don't always need to write A is equal to A minus 1. You just need to write A plus equal to 1, or A minus equal to 1, or A star equal to 1. Okay, I'm just gonna do that here. Like a is equal to a plus 1 can be written as a plus equal to 1. B is equal to b star 1, b star 10 is the same as b star equal to, and this also works for your your binary bitwise operators. So p left shift equal to 2. It's a left shift the b variable by 2 bits, 2-bit positions, and then reset it back to b. It's similar to writing b is equal to b left shift 2. Correct? So I have a for loop where I'm declaring here, I am checking the condition here, and I'm also changing the variable here. Same thing that I did here in 3 separate places, I just do in a single line. And this loop is similar to while. So first it initializes the integer I, checks if I is less than 10, and then does this body part. Afterwards it decrements or increments whatever it changes it here, goes back to the condition, does the body part, goes to the changing condition, body, change condition, body. So I'm gonna do C out I here. So I compile, I run. So 6 times I have yes, and then for I is equal to 0, I less than 10, print out I. So in the first thing, I will be 0. So I is less than 10, 0 less than 10, true, prints it, increments by 1, 1 less than 10, true, prints it, increments by 1, 2, 3, 4, 5, and so on. At the end, we'll have I is equal to 10, and 10 is not less than 10, so it won't print. Okay. So we covered a while loop, we covered a for loop. The last kind of peculiar loop, like I like to think of it that way, is the do while loop. Anyone know what a do while loop is?
Yeah, the do while loop, we check the condition at the end of the loop. Like we do a certain we do the certain function, and then we check for if the condition holds good. So the input enters the loop, and when we are exiting the loop, it checks whether the condition is met or not.
Perfect. That's all there is. So like in a while loop, this condition is checked like at the end, right? So this before doing anything, just does it once and then checks it. Like, okay, so here I initialized a to some value. It checked if a is equal to 0 and then did this. So the way you write a do while loop is we do, and then at the bottom you have a while. Okay. So what this does is it basically does whatever is in here, that it, and then checks if file is true. So let's say I am putting int j is equal to 10. I want to print j, and then I want to check if j is greater than 10. So if j is greater than 10, do this again. So if I compile this and run it and give some number, this 0 to 9 is from this for loop. This 10 is from this do while loop, and it printed 10. If I made this in a while loop, it will not print 10. Why? Because while is entry dependent. Entry to the while block depends on the entry condition, this condition. While do is on the exit dependent. So it checks after it does something. So it basically does this and then checks. But while it checks first and then does this. So both have their own use cases. But all of these loops have their own cases, but all of them are essentially the same. You can replicate a while loop with a do while loop. You can replicate a do while loop with a while loop. Just do this once there. Like I can just do this here once and do the while loop. It's the same stuff. I can move all of this into one line, making it a for loop. I can split all of this into multiple lines, making it a while loop. Okay, so those are the kind of loops we have in C++. There is one more kind of loop called a for each loop, but that is kind of complex. Like, to understand that, you'll have to learn about arrays and stuff. So I'm going to teach that later in the end. Like, after this, I still have to teach functions and then arrays. That's all I'm going to teach in the beginner session. I don't want to go too deep. Okay. So any doubts so far with input, output, data types, and loops? So I'm assuming no doubts. So I'm going to move on to the next thing. I'm going to teach you about functions. It isn't much because I don't want to overload you with a lot of information. There's a lot of stuff in functions. There's a lot of stuff in C++. I mean, there's a lot of stuff in any language if you go too deep. But since this is an introduction session, I am not going to go too deep. If you guys want, we'll work something out, and we'll hold another session for more intermediate stuff. Okay. So boilerplate code: hash include iostream int main and using namespace HTTP. What is a function? Well, similar to how you write loops to prevent you from writing the same thing over and over again, you write functions. So let's say this. This is my morning. How do I say this? There is some stuff that I want to do, and I want to keep doing it a lot of times. So during exam season, I have to wake up at a proper time. I have to get ready. I have to make sure my hall ticket and everything is in my bag. Reach the destination, like the college, at time, in the proper time. Get seated and then write it. Okay. Now, let's say you want to program all the students in the NIE. You can't just write. You can write like take the same bit of code and copy paste it multiple times, or a more better way, a more cleaner way of doing it is to write a function and then applying that function on anyone. So the way a function is written in C++ is that it's a structure you have to follow. It is first the return type, like what the function returns upon completion, the function name, brackets, and optional arguments, curly braces, and then body of the function. This is the basic structure of any function. I told you that int main is also a function. So compare these two. So what's the return type? Int, function name is main, optional argument, so there are no arguments here, and the body is empty. So let's say I want to make a program that squares every number I give it. So if I give it 4, it has to give me 16. If I give it 10, it has to give me 100. If I give it 10,000, it has to give me 10,000 squared. I don't know what that is, but yeah. So I'm going to make a function. So I'm going to need your help with this. What should it return? If I give it an integer and it squares it, what is the return type? That is the data type, the returned value. So if we square an integer, what will be the data type? It will still be an integer, right? Yes? No?
Yeah.
Okay. So the return type is int. Good. So next is square. Function name is square. Next, it takes an input. What input? What argument does it take? It takes an integer. So int a. I'm going to call it num actually, and brackets. So this is a function which returns a int. It has an integer argument. So I'm going to return num multiplied by num. So let's say I have an integer a is equal to 100. So, 2021, that's the year this time. So I'm going to do C out where of a, and I'm going to add a end line here distribution. So it doesn't say there's an error, so that's a good thing. I'm going to compile this, run the code. 408441. So 2021 over 2 is 408441. Is that right? Yeah, that's right. So what happened here? So we have an integer. We are passing the integer by value to here. We're passing the value of the integer to this function. And here we're multiplying num by itself. So essentially squaring it. And we're returning the value. And that returned value goes into the output. So the flow is basically from main. It goes to square. It goes back to main. It goes to cout. Okay. Now, do note that just because I passed a here and I'm multiplying it like squaring it here, that doesn't mean that a itself is squared. I am passing by a value. Passing by value. Okay. What that means is this passed value is it's just passing the value. It's not passing the variable actually. So if I print out out a here, compile and run it again, I still have 2021. This is useful in cases where you don't want the variable to be changed. You want the value to be changed, yes, but you don't want the value of the original variable to be changed. You want to use the value, do some kind of math, do some kind of computation and return it back. But you don't want to actually change the original variable's value. In some cases, though, you might want to change it. So in that case, in those instances, what will you do? Instead of passing it by value, you will pass it by reference. So I'm going to make another thing. I'm going to make another thing called cube. We take the same integer num. And here I'm actually not going to return anything. I'm going to do a void here. What does void mean? Void means nothing, empty. It's like the English meaning of void, empty, nothingness. So this is not returning anything. It's just doing stuff. And here, next to int, I'm going to give a and, the ampersand symbol. And I'm going to do num equal to num into num. Okay. And do num is equal to num star num here and do a return num here. So you get the difference. I'm not going to call this function yet. I'm just going to keep it as is. So I'm just going to compile again and run it. Now see, I did the same. This thing is doing num is equal to num star num and returning num. These values are not changed. So what I'm going to do next is I'm going to do cube of a. But instead of just passing a, I'm going to pass. Yeah, I'm just going to pass a. There's nothing else. I'm going to pass a and then I'm going to see out a. What do you expect is going to happen? And what do you think is going to happen?
The value of a has changed.
Yes. Why? Because this function is passing by reference. Now C also has something like this, but there you have to use pointers. Now pointers are, well, they're very fun. Don't get me wrong, they're very fun, but they're also very dangerous. Why? Because you'll be accessing the memory directly. Okay, so anyone here who doesn't know what a pointer is basically a reference to your memory, like the actual bit in your RAM or your hard disk, mostly your RAM. So if you say I have a pointer to the some address, you'll directly be messing with memory in your computer. That the ones and zeros in your computer are actually there. And if you mess something up, if instead of it's supposed to be a 1 but it became a 0 because of you, best case nothing happens, it's fine. Worst case your computer might actually crash. Okay, so C++ actually tries to actively stop you from using pointers. It doesn't like forbid you. You still can use a pointer if you know how to. If you know how to properly manage the pointer, you have to know how to use it effectively, safely. By all means, use it. But it is often best not to use it because it adds to a lot of complexity, and you have to spend a lot of time thinking what would be the consequences of me using this pointer and like incrementing this pointer, separating this pointer. Why the hassle? So C++ has things called references. So what it does, it essentially does the same thing as passing a pointer. It passes this entire variable there. It passes the reference to that variable. So this num is not pointing to its own num. It's pointing to A. But in Square, this num is actually a separate variable. It's actually a different variable by itself. It has its own memory. It has its own value. It has its own everything. Okay. But this num in cube is pointing to A. The same memory, the same value. So if I compile this and run this, I am getting negative. Oh, sorry, 2021 is a big number. Before I fix this, anyone know why this is being negative? Anyone have an idea why this is negative?
Int cannot hold that big of a number.
Yes. So in modern 64-bit computers, that is what I'm assuming all of you are using, int is 4 bytes, I think. Size of int. Yeah, it is 4 bytes. So 4 bytes means 4 into 8. 4 into 8 bits. So let's do the math here. 4 into 8. What is it? 32. So what is 2 power 32? 4294967296. This is the maximum like a 32-bit thing can hold. But since we have both positive and negative, it is actually this divided by 2. This is the theoretical maximum, the actual maximum that an integer can hold in C++. If you want to go longer, you have to use something else. Like I said, there are a lot of data types. The basic ones are these. If you want to go longer, you'll have to use something called a long int. If you want to go longer, you have to use a long int. You can just extend that how much ever you want. There is a limit, but usually an integer is enough. So I'm just going to reduce this to 9. That should be enough. I'm going to go back here, compile it again, and run it. So 81, a squared 81, a was still 9, not changed. I'm calling cube here, and I print it out, it's 729. Why? A changed. Why is that? Why? Because I'm passing by reference. So do you guys understand the difference between passing by value and passing by reference?
Yeah.
Cool. So I mean, this is all there is to of like functions. The most important bit of a function is actually what goes inside it. So depending on what you want to do, you can do it. And you can also mix and match loops with functions. So I can write this function, I can write this function, I can write it here, and I can just call this function in here. I can just call cout square of a. So one thing which stopped me from writing this bit of code every single time And another thing is stop it from writing this bit of code every single time for while. So this way you can, make your code shorter, cleaner, and crisper, like easier to understand and read. So any doubts with functions? Like how to write a function, how to call the function, passing by value versus passing by reference. I'm not saying this is not the entire bit. There is a lot more to learn about functions, but for beginners, this should be enough. So if this is done, I'm going to go to the last topic, which is arrays, because arrays are kind of useful everywhere. So the last topic is arrays. Arrays.cpp. Yes. So let's start with what an array is. An array is actually, like I said, you know what a string is, right? A string is a set of characters. Actually, a string is also an array. It is an array of characters. So what do you think an array means? An array is a set of similar elements. Elements of the same data type all together as a set or like a collection is called an array. So I'm gonna write the same boilerplate code here. Hash include iostream using namespace std int name. Here I have integer a is equal to 10. I want to make another variable that holds not just one value, but 5 values. So instead of doing int b is equal to 2, int c is equal to 3, int e is equal to 4, int e is equal to 6, oh god, it's too much. So doing 5, I want one variable to replace all these 5. And the solution for that is arrays. So how do I declare an array? If you guys have experience with C, you'll know that writing arrays is basically you write the data type first. I give the data type, okay, and I have to give the variable name, just like any other variable. I'm gonna name it ARR array. Here's the important bit. I have to give square brackets, and I have to specify the number of elements in my array. Now I want to replace these 5 with 1, so 5. So this ARR is a variable which holds 5 elements. Well, which can hold 5 elements. It's not holding 5 elements like the ones I want right now, but it can hold the 5 elements I want if I give it to them. So instead of this, do this. Turn 5 variables to 1. Okay. So I have declared an array. I want to give it the values. I'm just going to initialize it right here for now. The way you initialize it is you do an equal to and these floor brackets. And then I give the values I want. So I want to give 1, 2, 3, 4, and 5. If I go over this, if I give 6, it'll throw an error. Too many initializer values. For 5, it should actually be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But I gave 6. That's the problem. But if I give 1 less, it doesn't matter. So when I declare some of them and don't declare the rest become initialized to 0. So I'm gonna make it 5 for now. Make it for 5 now, and we're gonna use it. So how do I use the array? Well, arrays work on something called indexing. What indexing means is each of these elements is associated with one integer, an index as it's called, so that if you use the index and the array together, you'll be able to get that element. If for the second and third years of you, if you studied algorithms and analysis of algorithms, you'll know that you have something called the big O notation or the theta notation. like O of something. So arrays are O of n, O of 1 actually. They are constant lookup times. So you don't need to search for the array to find the element. If you know the index, if you already know the index, just use the index and get it instantly. So how do I use the index? So let's say I want to print the first element, array of 0. Okay. So the 0th index is the first element. Remember that in most programming languages, like most of them, not all of them, I'm not saying all, MATLAB is an exception. In most languages, the indexing starts with 0. So if I save this, if I compile this, and if I run this, I get 1. If I change this to 4, I get the last element. So 1 is so I'm just going to name this 0. I'm just going to make the 0, 1, 2, 3, 4. So this is in index 0, index 1, index 2, index 3, and index 4. Got it? So indexes start with 0. You can also take inputs to an array. So I'm going to do that here. I'm going to create an integer array A of 3 elements. I'm going to initialize it. I'm going to put a for loop for int I is equal to 0, I less than 3, I plus plus. So this loop will run for how many times? 3 times. 0, 1, 2. I'm going to do a cin array A of I. So this takes the input and puts it in the ith index of the array. So I'm gonna print also. I'm just gonna print this also here. For int is I won't print it. I'm gonna show you the for each loop later. I want to override it. So this is how you take input. So I'm just gonna compile and run this. I can give 1, 2, 3. So this 1, 2, 3 will be stored in array. How do I check it? Before I go there, any doubts? Arrays? Did I go too fast, too slow, or anything? No doubts?
No doubts.
Okay. So I'm going to show you the extra, like the special kind of loop called a for each loop. So a for each loop is basically the same keyword as a for. Instead of writing int I and using indexes, I'm going to say I'm going to say auto. Auto is a keyword which if I don't care about the type. It can be whatever it wants. Let the compiler infer it. Okay. Auto item for array of X. Auto keyword will basically mean let the compiler infer the type. You don't need to worry about the type. Let the compiler by itself decide it. It should be int because each element in this array is an integer. But auto is easier to write. I'm just gonna see out item and enter. Every element in this array gets stored in this item variable, and I'm printing it out. And then goes back to the loop, gets the next item, prints it out. So I'm gonna compile this and gonna run this. I'm gonna give 0, 10, and 123. I get back 0, 10, 123. Got it? I can even do math on this. I can do multiply by 2. If I compile and run again, 1, 2, 3, I get 2, 4, 6. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So you know what an array is? You know how to store stuff in an array initially, how to write stuff to an array, and how to get stuff from an array. You get it through indexes and you write it through indexes also. One important thing to notice, arrays are fixed size. What I mean is, once you make an array, let's say I make an array of 100 elements. If I want to increase the length, I cannot increase it. I'll have to make a new array, copy everything over, and then only will I have the extra space. So arrays are good, but if you have like a dynamic length, you cannot use arrays. It's harder to use arrays. For dynamic length, there are a lot of containers in the C++ standard library, but they are a bit more advanced. So hopefully, if we take a intermediate session, I'll be teaching you about the C++ STL functions. And yeah, hope to see you soon in further sessions, and hopefully offline. Thank you.